guys, so maggot problem, oh my. So the problem, and this is something that really happened. This isn't something I'm making up, like this was a real life thing back in the day. But their problem, they were like, why are we getting maggots on food? So that's always the first step in any scientific process. You guys notice something, you observe something. And their observation, they say the problem is, why are maggots getting on food? Now, do you guys, anybody in here not seen a maggot? Has everybody in here seen maggots at some point? Yeah, nasty little things. So then, of course, once we state a problem, we then have to form a hypothesis. Just like last week, the problem was, it's not really a problem, it's more of a question. Which of your senses is better? And then you guys formed your hypothesis. So go ahead right now, without me saying anything, you write down your hypothesis. And remember, it's okay if it's wrong. If your hypothesis doesn't have to be correct. It's okay if you're wrong. But why do you think maggots get on food? Write that down. And remember, back then they had no clue. So there were some hypotheses that were crazy, and we'll talk about those. But they had to test. Because once somebody forms a hypothesis and they're like, oh, it's because of, we'll talk about some of them. You have to test to prove that you're right. Yeah.
Are maggots like baby flies?
Are what? What'd you say?
Baby flies.
Baby flies, yes. And we were going to talk about that because I know in the past some people haven't known what maggots are. They maybe have seen them, but they don't know what they are because they do look like little worms, right? So it's not, a lot of people think that they are just worms. All right, so what's a hypothesis I could write down? You said that they come from baby flies, so what was your hypothesis then?
They're going to do some fly things.
They're going to do some fly things? Okay, well,
Food
so...
it's not preserved right. The flies are in later eggs.
Yeah, so to get that if-then, because that's what I had you guys do in the senses lab, I'll show you what I wrote down. If maggots, because some scientists did say maggots come from flies. If maggots come from flies, so there's that if statement. So here comes my then. If they come from flies, then, and there's so many ways you can word this, then flies lay eggs on food. So there's that if then. So now we're going to look at a few scientists and what they thought. Because here's the problem. The first guy, he had it. He hit the nail on the head. Back then, of course, they didn't know for sure. So he was going to try it out. So Reddy. This guy Reddy, he said the same thing that you said. He was like, I think the flies are producing the maggots. He said, flies produce maggots. Maggots. So walking through the scientific process, once he said this, once he had a hypothesis, you can't just go around telling people that. If you're a scientist, you have to then do a test to prove it. So once you have your hypothesis, you're going to do an experiment. So that's what he did. So I'm going to see what you guys can talk as a table or whatever with the people around you. And I want you guys to come up with an experiment. Is it okay if if I scroll up, that does that. Is it okay if I get rid of this? Everybody good? Okay. Clear ink. So here's Reddy. That's that guy. So I want you guys, if we are saying that maggots come from flies, and you have somebody saying, prove it to me. If you're going to say that, you have to prove it to me. What kind of test would you set up? You're saying that, yeah. Well, right now, before you answer, get with your table or with people around you, and you can draw out your experiment or write down what you would do. Okay? So go ahead, write down or draw. You can do a drawing of it. I like to draw things out, so you do whatever is comfortable for you. So those of you at home, you go ahead and you try to draw out or write it down also. Okay, there it goes. All right. So back to our experiment. Guys, anybody want to share their experiment with me? Yes, Owen.
X amount of apples exposed to flies, X amount of apples not exposed to flies. See how many maggots there are.
Okay, so I'm gonna, oh my gosh, you guys are getting ready to see my amazing drawing abilities here. So just a heads up, since you're freshmen, never had me before, I cannot draw at all. But you're gonna see me try to draw all the time. So we'll see how this goes. I'm gonna draw, there's my apple, okay? So we have apples that are exposed to flies and apples that aren't. Oh my gosh. I'm just gonna draw the apple.
However many you want to put.
I'm just gonna draw one apple so I don't have to keep trying to draw these things. Okay. That's my apple anyway, little circles up there, lost. Okay, so I have flies with one apple. I'm gonna draw a little fly body up there. And the other apple does not have any. So are they just sitting out in a room? Where are they at?
If they're like one, like they're in a secure area, one's exposed to flies, so one's like say a little box with flies in it, and then one's not.
Okay, so one's like in a box with flies in it?
Yeah, one's in the exact same kind of box, but with no flies.
Okay, good. That's what I was looking for.
But both the exact same environment, lighting,
Yes,
water, like,
which is keeping, yes, keeping everything, only two variables. Good. So he's making sure all the variables are the same. So it would be like literally putting two boxes just sitting in right here, so they're in the same environment, but there's boxes and one has flies in it and one doesn't. All right, that's a good experiment. Now there's definitely other ways you could do this, and tomorrow you guys might come up with, each group may come up with a different way, which is fine. There is no right or wrong as long as it's a controlled experiment. So anyways, if that's what you would do, fine. So let's look and see what Reddy did. He did something very similar to this. Let me clear that ink. And I'm going to draw now. What?
I like that guy.
You like that guy?
Yeah, I like it. Look at that dude.
Alright, so what he did is he had, kind of like you did, he had these jars. So if you guys want to draw along with me. And he put, instead of apples, he put meat in these jars. So this was an uncovered. So he instead of having it in a box, he just had a jar with uncovered, and he didn't necessarily leave flies in there, he just left it out for the environment. Now he had another one. I'm not going to write out to the side what this is. He had another one with meat. But this time he covered this thing. So this one's covered. So that nothing could get into it.
I think mine was better, because that one got like more outside.
Well, that's where we're going to get where scientists argue with him. So he did this, and guess which one ended up with maggots on it? The uncovered. So what ended up happening, so my results, and I'll write results, this had maggots, this one had no maggots. So if I'm looking at this experiment overall, I've got maggots versus if it was covered, right? Maggots versus the type of jar. So let's look at this. I'm just going to maggots versus type of jar. Which one's my dependent and which one's my independent? Yeah.
The maggots is dependent and the type of jar is independent.
Yes, if you have maggots, depends on what kind of jar you have, right? So there's my dependent versus my independent. And this is my control. If you're trying to see if flies are producing the maggots, then your control is going to be your covered one, right? It's the one where you're like, this is what happens if there are no flies around. So this would be my control. Because this is what I'm testing. I'm really testing this one right here. So the other one's my control to see what happens if there are no flies. All right. So let's look at what happened here. So if we're doing this, you guys, like you did with the census lab, you did an experiment. The next step was to get your data, which we did, he has his data. Do your results. So that's where we're going to go next. His recorded data, his results. So we're just walking through a lab. Has everybody got this part? All right. All right, so he's recorded data. So what he would have said, and his data may have been a chart with jar number 1. This is maggots appear. Jar number 2, maggots appear. Jar number 3, maggots uncovered. Jar 1, none, none, none. Like just kind of visually seeing what he wrote. That might be his data, and then his results are going to explain what that data says. So what the explanation is that maggots appeared in uncovered jar. So that would be his recorded results, and he would have to put, of course, I'm trying to just be quick about it, he would also have to put no maggots in covered. So I'm real quickly writing stuff down. You guys would write complete sentences when you're doing yours. So then, once you have your data, just kind of like you did in your census on that back sheet, there's then a conclusion. So his conclusion is he supports his hypothesis that flies produce maggots. Now, usually your hypothesis, which we'll talk more about when you do your lab, it says a little bit more. It tells you if there's any errors, if you would improve on your lab, if you would do more tests. It would mention all this stuff in your conclusion. Your conclusion usually ends up being about a paragraph. But real quickly, yes, he supports his hypothesis. Flies produce maggots. Once you do a conclusion as a scientist, publish your results. Other scientists can then look over the work and retest. This is what happened with the maggot experiment. I mean, back then, people truly did not know where they came from. These are scientists just saying these things and testing them. Like, it's important that we do that. Is there something today that maybe we are so sure on and people are going to look back on us one day and be like, can you believe that they did that? Have you guys ever learned about the black plague?
Yeah.
In here, did you hear like what some people did to think that they would cure themselves? They would sit in their own urine because they thought that was going to help them not get this plague. Could you imagine if people were doing that today with like COVID? People would look back on this and be like, they were crazy. What were they doing? Maybe they will look back on this one day and be like, they were crazy. But we look back on some of this stuff and we think it's so silly. Like, how did they not know when they didn't know? So anyways, that's why you have to publish the results and you have to say this. All right, so here's where it gets crazy. We have like normalcy right here. And then we have a scientist that's like, no, this is not right. So let's look at that. We have Needham here. I believe it's John Needham. And his argument is, and this is where I'm like, this was for real. People thought this back in the day. Spontaneous generation. He said, spontaneous generation can occur under the right conditions. Now, spontaneous spontaneous generation is literally that something just appears. Yeah, poof out of thin air, I had a student there. Something living just all of a sudden came out of nowhere. Alright, so he said though, that they have to have special conditions. Okay, and he's just saying that